Imagine waking up on the beach before dawn. The glimmer of light leads you to the shoreline. Suddenly, a wave pulls you in. At first, you use the direction of the waves to guide you. But once you're in the open sea, with powerful currents bombarding you, and very little light, how can you be sure of where you are and where you're going? For a hatchling sea turtle, the answer is magnetoreception. That's the ability to sense magnetic fields. We know many animals use this sixth sense for navigation. What we don't know is exactly how magnetoreception works. Here's what we do know. Earth itself is like a giant magnet. The motion from its liquid outer core generates a magnetic field. Certain animals can sense this field and use it as a compass to tell them if they're heading in the right direction, and a map to give them signposts along the way.
There's two competing theories for how magnetoreception works. One is a chemical sensor, the other is a mechanical sensor.
The first theory is that animals have tiny magnetite particles in their bodies that act as magnetic receptors. Magnetite is the most magnetic natural metal on Earth. It's been found in many animals that exhibit magnetoreception.
And it's thought that it's the only potential sensor that would be sensitive enough to capture these incredibly tiny variations in magnetic field strength that would allow the animal to not just know whether they're going north or south along a magnetic field line, but know the precise beach that they need to get to.
The other theory is that animals possess a protein in their eyes called cryptochrome, which allows them to see magnetic fields. Cryptochrome has been found in the eyes of several migratory birds, but we haven't proven either theory for a few reasons.
With magnetoreception, you don't know where to look. Magnetic fields pass invisibly through the entire body, so researchers don't know exactly where these magnetite particles or cryptochromes would be attached to particular cells. So mistakes are made all the time.
And so far, cryptochrome experiments have only yielded positive results in the presence of magnetic fields much stronger than Earth's.
The frontier is now not so much at the animal behavior level, but actually getting inside the brains of these animals and trying to find these sensing cells and connecting them to the neural circuitry. It's not so much a question of which animals have this sense, but which don't. So researchers have said, well, why not humans? Maybe we had this sense at one point deep in our evolutionary past and lost it, but maybe there's a vestige left. Researchers in California and Japan have gone after this holy grail one more time with a very specialized experiment, one that relies on double blinding and magnetic shielding, and they're seeing glimmers, maybe even more than glimmers, of this magnetic sense in humans. It's starting to be reproducible, and they're really excited about it.